Problem number 3, we're asked to evaluate this integral using geometry, using properties of integral only. We're not trying to find antiderivatives of things here. How do we do this? I'm going to break this integrand up into 2 parts here. This is the integral from 0 to square root 10 of x dx, plus the integral from 0 to square root 10 of square root of 10 minus x squared dx. Okay, what is going on in each one of these pieces? We're going to figure out each one of these integrals by thinking about areas under curves. Okay, this right here, x, so let me draw the line using a different marker here. Okay, this is the curve y is equal to x, and right here I have the line x is equal to square root of 10. And so this first integral is this area right here. What is this area? This is the area of a triangle with a base length square root 10, height square root 10. What is the area? It's 1/2 times square root 10 squared. Square root 10 squared is 10. This is 5. Okay, how about this integral over here? So we're thinking about the curve. Y is equal to the square root of 10 minus x squared. Squaring both sides gives us y squared is equal to 10 minus x squared. Or x squared plus y squared is equal to 10. Okay, what is going on with this right here? This is a circle of radius square root 10 centered at the origin. And we have an intercept here at square root 10. We have an intercept here at square root 10. So this integral is asking us to find the area under the curve above the x-axis here, as x runs from 0 to 10. It's this area right here. What is this area? In geometry terms, this is just a quarter of the circle. It's just not a very, the circle is a little bit off center here. That's okay. It's a quarter of a circle of radius square root 10. We know that the area of the entire circle is pi times the radius squared. The radius is square root 10, so this is 10 pi. And so our area of the quarter circle is a quarter of this is 5/2 times pi. So what is our final answer? We can get this without doing any, finding antiderivatives, any functions here. It's 5 plus 5/2 pi. This gave us 5, this gave us 5/2 pi. Okay, problem number 4, another picture problem here. Curve y is equal to 25 minus x squared, as shown in the figure below. Calculate area of the shaded region here. Well, the thing that we need to know here, what is this intercept? This is when 25 minus x squared is equal to 0 here. X is equal to plus or minus 5. This is the positive root here, so this is 5. So what's going on here? This is asking us for the integral from 2 to 5 of 25 minus x squared dx. Because we're finding the area under this curve here. This is what we're being asked for. Okay, what is our answer? 25x minus x cubed over 3. Plug in x from 2 to 5. When x is 5, we get 125 minus 125 over 3 minus, plug in x is equal to 2. 25 times 2 is 50 minus 8/3 there. And this is a perfectly fine final answer. Okay, one more problem in this video here. Find the unique positive value of a such that the integral from 0 to a of x over x squared plus 1 dx is equal to 3. We're going to evaluate this by substitution. So x squared plus 1 is going to be our u. And so then du will equal 2x dx. Why did I choose x squared plus 1 to be my u here? Because, you know, this is the nastiest part of the integrand here, and there's a nice feature. The derivative of x squared plus 1 ends up being 2x here. So du is 2x dx. If I divide both sides here by 2, du over 2 is equal to x dx. And oh look, I see an x dx right there. Okay, so this is x dx. Okay, so du over 2, x squared plus 1 is u. We have to change the bounds in our definite integral here. How do we do that? When x is equal to 0, u is equal to 0 squared plus 1 is 1. And when x is equal to a, u is equal to a squared plus 1. Can't really do much else with that. So these are the bounds on our integral. So from 1 to a squared plus 1. Okay, let's see, what can we do? Divide here by 2, I'm going to move that outside the integral as 1/2. The antiderivative of 1 over u, and the antiderivative is natural log of absolute value of u. So I should put absolute value bars here, but the things I'm plugging in are going to be positive. So I can just put this here, plug in from 1 to a squared plus 1 here. So this is going to be 1/2 log of a squared plus 1 minus log of 1 here. Log of 1 is 0. Natural log of 1 is 0. So this is just 1/2 natural log of a squared plus 1. Okay, we evaluate the integral here. We want this to equal 3. So then the punchline, the final part of this, is that we need to solve this equation here for a. Multiplying on both sides by 2 gives us natural log of a squared plus 1 is equal to 3 times 2 is 6. Doing e to the both sides here, a squared plus 1 needs to equal e to the 6. A squared is going to equal to e to the 6 minus 1, and take the square root of that. A is equal to the square root of e to the 6 minus 1. We don't have to worry about plus or minus because the problem specifically asked us for a positive value of a.